We are here today to build a working model of the Circle of Willis. So, as you know, blood circulation starts in the heart, so here's a heart for you in my little coffee can, and I'm going to place it down on the floor because, as in the human body, the blood is flowing from inferior anatomical parts up to the head and neck. So, we put it right down there, and the first thing I'm going to do is build the posterior part of the Circle of Willis. So we'll start out with these ropes. So the ropes are arteries, okay? So I'm going to place the rope in here in the heart. We're going to start with the vertebral arteries, which come up from the aorta. This is the person's right artery. This is the person's left artery on this side. So I need someone to volunteer to be the right vertebral artery. Can I get someone? We have a whole bunch of student volunteers from ASU, and if you want to get down on your knees, if you can. Okay, and I need a left vertebral artery. So can we get a volunteer there? Thank you. So I lied about the tall people thing for this. Okay, so anyway, we've got blood coming out of the heart, separating into the vertebral arteries. The vertebral arteries continue up all through the vertebrae till they get to the base of the skull. At that point, the vertebral arteries are going to anastomose. So they're going to come together, merge, and turn into one. This tiny little writing here says basilar artery. So that is a basilar artery. Can I have a basilar artery volunteer? Okay. Thank you, Mr. Basilar. Okay, so you might need to get down on your knees too.
Okay.
Yeah, that's good. Okay, so the basilar artery, after the vertebral arteries have anastomose, then they're going to have some bifurcation again. So they're going to separate, and they're going to form the posterior cerebral arteries. So can I have a tall person here to be the right posterior cerebral artery and the left posterior cerebral artery? If you can kind of do some housekeeping, help those two. So now, off of the basilar artery, I haven't indicated, there will be some smaller little cerebellar arteries that go to the cerebellum, but it gets really busy and complicated if we include those too. So this is the posterior part of the Circle of Willis, but as you see, we don't have a circle, so we need to do some more building. So now I'm going to get the anterior part of the Circle of Willis. The first thing that happens is the carotid arteries rise out of the heart, off of the aorta, and I need someone to be a right carotid artery. Can we get a volunteer? Okay, that one right there. And then it's a symmetric system, so of course we have a left carotid artery. Okay, so the left carotid artery and the right carotid artery are headed up toward the head and neck. And then what happens is, part of the carotid artery moves toward the front. It moves anteriorly to serve the face, and it's the external carotid artery. So I need a left external carotid artery. We'll just put that on your shoulder for a moment. And then I need a right external carotid artery. There it is. So can I get a volunteer here? Okay, so you guys can probably get on your knees too, because we're going to build some other things here. The internal carotid artery, the left and the right, let me squeeze in here. Sorry. They continue going northward, okay, superiorly into the cranium. So we've got the internal carotid artery that is what comes in to provide blood supply for the front part of the brain. So what happens is this internal carotid artery comes to a point where it also bifurcates into the middle and the anterior cerebral artery. So at this point I need someone to sneak in here and be the right internal carotid artery. Anybody? Okay. And just so you're holding on to that label. And then somebody else to be the left one. Thank you. Okay, so we're getting close. So what happens is, excuse me, the middle cerebral artery branches off of the external carotid, or the internal carotid. So can I get a, oops, we've got twisted signage here. Pretend like you can read it and it says MCA, okay, not W. Okay, so we'll have the middle cerebral artery right here. Can somebody come grab that one? And then guess what? There'll be a middle cerebral artery on the left, or on the right side. Okay, so the MCA would be going off to the lateral margin right there, okay? And then, as you can imagine, the anterior cerebral artery will come forward to serve the frontal lobe and the medial portion of the frontal parietal lobes. Can I get a volunteer? Okay. Excuse me. And we need an anterior cerebral artery here. Okay, so right now we have what looks like a spider's web nest of complicated, interconnected, but disastrous fibers. So the thing is, the way it is right now, there's no connection between the posterior section and the anterior section of the circle of Willis. So there are these other arteries that are really important to the circle of Willis. The first thing I'm going to give you is the artery that connects the posterior system to the anterior system. So what we're going to do is we're going to take a posterior communicating artery right there. We're going to tie it to part of the PCA here, and we're going to connect it to the MCA, the middle cerebral artery. So I'm going to go around my friend the carotid artery. You might want to get down a little bit. So this is the MCA, not the WCA, but the MCA. And we're going to connect those two. Okay, so there is the left posterior communicating artery. We have the same thing on the other side. The right posterior communicating artery is going to go from the PCA, connect to the middle cerebral artery. So now, if let's say you have a problem in your middle cerebral artery, there's something that, there's a problem here in the carotid artery, and there's blood flow is not able to come to this part of the brain, the lateral portion of the brain. Blood flow can come from the vertebral arteries to the PCA, travel along this handy-dandy communicating artery, get to the middle cerebral artery, and provide vascularization to these brain tissues. So it's a great insurance policy. And to complete the whole story, let's say you have a problem. Let's say you have a problem here. This part's not getting blood flow, but you can take your anterior communicating artery. It's going to connect these two. So we're going to have a small little artery that connects the ACA on the right side to the ACA on the left side. Okay. And now you can see I'm kind of inside the circle, right? So the circle of Willis would be the ACOA, communicating artery, part of the ACA, the MCA, and then we have that posterior communicating artery that goes around my friend here. Goes to the PCA, we have the PCA, and so the whole thing makes a circle. So the idea is kind of like the street around l'Arc de Triomphe in France, where you've got this circulation going around, and at any time somebody can go off and somebody can come in, and you've got blood flow that's provided. And so this is the insurance policy for the whole circle of Willis, the whole brain. It's a little bit busy because we're not looking at 3D anymore, we're looking at 2D, but you can clearly see that there is a circle of circulation that is allowing for all those cranial surfaces and sections of the brain to have more than one way to get blood flow. So that, in a nutshell, or in a big nutshell, is the circle of Willis. Thank you, everybody. Didn't they do a good job?